11:58 p.m. Strait of Hormuz. Inbound shipping lane, 16 nautical miles from the Iranian coast. The USS Mahan was 34 minutes into her inbound strait transit when her AN/SLQ-32 electronic warfare suite generated a warning that had never appeared during any of her previous 11 strait transits. Not a new threat type, a known threat type, but from a direction and at a power level that changed the nature of the warning entirely. A surface search radar operating on a frequency and waveform consistent with an Iranian Sistan-class patrol boat's navigation and fire control suite was painting the Mahan at close range. Not from the Iranian coast, from inside the inbound shipping lane itself. From a contact that the surface radar was showing as a commercial cargo vessel at approximately 1.8 nautical miles, in the same lane, on a parallel course. A commercial vessel with an Iranian military radar aboard. American forces launched an immediate counter-operation at 02 a.m. Welcome to Navy Strikeforce. Today, we're going inside the 144 minutes that followed that detection. 144 minutes in which a covert Iranian fire control radar operating from inside the Strait's commercial traffic, an American counter-operation that had to develop a response in the absence of standing doctrine for this specific scenario, and a joint intelligence and legal exploitation effort that produced findings about Iranian use of commercial cover for military surveillance operations in international shipping lanes that changed Fifth Fleet's maritime surveillance protocols for strait transits, produced the most operationally complex, non-kinetic strait incident of the year. This is what it looks like when the surveillance operation is not on the coast and not on an obvious military vessel, but in the lane with you. And why the response to that scenario requires tools that are not in the standard playbook for a surface combatant facing an Iranian military contact in the Strait. To understand why a military radar operating from a commercial vessel at 1.8 nautical miles inside the inbound shipping lane creates a more dangerous and more legally complex situation than the same radar operating from a coastal site or a military vessel, you need to understand the distinction between the two scenarios across three dimensions: operational, legal, and doctrinal. Operationally, a fire control radar from a commercial vessel at 1.8 nautical miles has a geometry advantage that a coastal radar at 30 nautical miles does not. At 1.8 miles, the radar's target motion analysis is highly precise. The small range errors associated with radar systems at close range are minimized. The bearing accuracy is maximized, and the target's propulsion acoustic signature is potentially collectible by passive means at the same time. Close-range fire control radar data, combined with close-range acoustic collection, produces a targeting package with substantially higher accuracy than the equivalent data collected from 30 nautical miles. Legally, a military radar operating from a clearly identified military vessel in the Strait can be addressed under maritime law provisions related to threatening behavior toward a warship. A military radar operating from inside a vessel displaying commercial vessel markings and AIS registration creates a much more complex legal situation. The 1982 UNCLOS provides rights of innocent passage through international straits. A commercial vessel in the inbound shipping lane is exercising those rights. If the vessel's conduct is otherwise consistent with innocent passage, it is legally more difficult to challenge than an obvious military vessel behaving aggressively. Doctrinally, Fifth Fleet's standing guidelines for responding to surveillance of U.S. warships in the Strait had been developed for coast-based radar operations and for identified military vessels. They had not specifically addressed the scenario of covert military capability operated from within commercial cover. The watch officer who received the SLQ-32 warning at 11:58 p.m. had no standing doctrine to apply. She had a fire control radar warning, a commercial vessel as the apparent source, and a commanding officer who was looking at the same picture and reaching the same conclusion. This was a new problem. The commanding officer reported the contact to Fifth Fleet at 0000 a.m. and requested immediate guidance. Fifth Fleet acknowledged at 0001 a.m. and began developing a response. At 0002 a.m., the moment the incident clock starts. Fifth Fleet launched the counter-operation with the 4 elements available under the circumstances. The first element was identification. A P-8A Poseidon on orbit 90 nautical miles south was immediately tasked to conduct a close-range pass on the contact vessel, using its high-resolution maritime patrol radar and electro-optical cameras to document the vessel's full configuration, markings, hull form, antenna array, and any visible military equipment. The P-8A arrived at 0:19 a.m. The second element was electronic exploitation. The Mahan's own SLQ-32 was directed to conduct a full characterization of the radar emissions from the contact vessel. Not just threat warning, but detailed waveform analysis, frequency mapping, and power level documentation, creating an electronic fingerprint of the radar system being operated from the vessel. The third element was AIS verification. The contact vessel was displaying an AIS identification, a registered vessel name, and IMO number that placed it in the commercial shipping database as a general cargo vessel registered in a third country flag state. Fifth Fleet's Maritime Operations Center began a real-time verification of the AIS data. Was the vessel actually the ship it claimed to be, at the position it claimed to be at, operating the way that ship type would normally operate? The fourth element was legal documentation. A dedicated watch officer at Fifth Fleet began building a real-time legal incident record, documenting the radar warning, the vessel's AIS data, the Mahan's position and course, and every subsequent event in a format that could support a formal diplomatic protest and, if necessary, a challenge to the vessel's claimed innocent passage status. The P-8A's imagery, transmitted at 0:22 a.m., was the first piece of evidence to partially resolve the identification question. The vessel was displaying the name and markings of the registered general cargo ship whose AIS was broadcasting. The hull form was consistent with the registered vessel type, a general-purpose cargo ship of approximately 3,500 to 4,000 tons. But the imagery identified a communications and sensor array on the vessel's superstructure that was inconsistent with the registered vessel type's normal fit. Specifically, a rotating antenna assembly on the port bridge wing, whose form and mount type was not a commercial navigation radar. It was, in the P-8A imagery analyst's assessment, consistent with a military surface search and fire control radar system, externally mounted on a bracket assembly that appeared to have been added to the bridge wing, rather than integrated into the original vessel design. An aftermarket military radar mount on a commercial cargo vessel. The SLQ-32 characterization, completed at 0:24 a.m., confirmed that the radar emissions were consistent with an Iranian Sistan-class patrol boat's fire control system, not a commercial navigation radar system of any kind. The frequency, waveform, power density, and beam characteristics were military origin. The AIS verification, completed at 0:27 a.m., found that the genuine registered vessel, the cargo ship whose name and IMO the contact was displaying, was currently berthed at a port in the UAE, according to satellite imagery collected earlier that day. The vessel in the Strait's inbound lane was not the vessel it claimed to be. It was displaying a spoofed AIS identity, military radar, spoofed AIS in the inbound shipping lane. At 0:29 a.m., Fifth Fleet had a complete enough picture to act on. An Iranian military surveillance operation using a vessel with a false commercial identity and a covertly installed fire control radar system operating inside the Strait's international shipping lane, conducting close-range fire control radar collection on a U.S. Navy destroyer. The response had to be calibrated against the legal complexity of the situation. The vessel was in international waters, in an internationally recognized transit corridor, not displaying obvious military markings. Ordering the Mahan to physically challenge the vessel or issuing a boarding request required navigational proximity in a busy shipping lane with significant collision risk. A show of force by aircraft would not resolve the AIS spoofing situation. It would deter continued radar operation, but would allow the vessel to disengage and transit out of the strait without the identity fraud being formally documented for diplomatic purposes. Fifth Fleet chose a combination. The Mahan transmitted a direct challenge on Channel 16, and the military coordination frequency naming the vessel by its false AIS identity and stating that the vessel's emissions were inconsistent with commercial navigation operations and were being formally documented as a potential hostile surveillance act. Simultaneously, the P-8A was directed to maintain a surveillance orbit over the contact vessel for the remainder of the Strait transit, photographing the vessel continuously to document its behavior. At 0:31 a.m., the SLQ-32 warning ceased. The radar emissions from the contact vessel stopped. The vessel maintained its course and speed in the inbound lane. It did not alter course or accelerate. It continued on a normal commercial transit bearing through the strait. At 1:14 a.m., the contact vessel cleared the strait's western exit into the Gulf. The P-8A maintained its orbit until the vessel was 30 nautical miles west of the strait before breaking off. Total continuous P-8A documentation, 55 minutes. The Mahan completed her own inbound transit at 0:52 a.m. and continued to her assigned patrol sector. The intelligence and legal exploitation produced findings over the following 3 weeks that drove immediate changes to Fifth Fleet Strait transit protocols. The AIS spoofing was the most technically significant finding. The vessel had been broadcasting the identity of a real, registered commercial ship, a fraud that required access to that ship's AIS data and technical capability to rebroadcast it from a different vessel. The technical capability was not sophisticated. AIS spoofing equipment was commercially available, but the operational preparation required knowing which vessel's identity to spoof and ensuring that the genuine vessel was not also transiting the strait at the same time, which would have created 2 simultaneous contacts with identical AIS signatures. This preparation indicated prior planning and surveillance of the genuine vessel's schedule. Information obtainable from commercial maritime databases that post vessel arrival and departure records. The post-incident guidance change addressed 2 vulnerabilities. First, the Strait Transit Warning Order for U.S. Navy vessels was updated to include active SLQ-32 operation in characterization mode throughout the transit, not just in response to a specific warning, but continuously to detect anomalous radar emissions from nearby vessels before they had been operating long enough to collect substantial targeting data. The Mahan had received the warning after the radar had presumably been operating for some time during the preceding 34 minutes of transit. Second, the Fifth Fleet Maritime Operations Center implemented a real-time AIS verification capability for vessels within 2 nautical miles of U.S. Navy ships transiting the strait, cross-referencing AIS identities against satellite imagery of their registered home ports to detect the same spoofing pattern that the Mahan incident had exposed. Both changes were implemented within 30 days. The vessel was never identified. Despite the P-8A imagery, the hull markings it had been displaying were sufficient to obscure the vessel's actual identity on camera at the ranges and angles the P-8A had been able to achieve. The third country flag state, whose registry the genuine vessel had been using, was notified through diplomatic channels that its flag had been used to cover an Iranian military surveillance operation. The notification produced no useful response. The radar had been active for at least 34 minutes before the SLQ-32 detection, and possibly longer. From the moment the vessel had entered the strait behind the Mahan's inbound transit, its radar could theoretically have been operating while the Mahan's EW suite was in its standard, rather than characterization mode. 34 minutes minimum, possibly more. Close-range fire control data on the Mahan's hull, course, speed, and propulsion signature. The counter-operation had documented the vessel, stopped the radar operation, and produced the evidence needed for a diplomatic protest and a protocol update. It had done everything available to it. But the SLQ-32 had been in standard rather than characterization mode for the first 34 minutes of the transit. Under the new continuous characterization guidance, that window closed. It closed for future transits. The 34 minutes the Mahan had already given up were in whatever system had been receiving the radar's data output. The counter operation had started at 02 a.m. The radar had started before 11:24 p.m. Stay sharp, stay informed. This is Navy Strikeforce. We'll see you in the next one.